Welcome to this intro video for Module 2 of MCET 450 Advanced Mechanics. In this video, we will get an overview of the three main software programs used in this course. In class, we will practice using them together. All three of these programs can be considered computational software. MATLAB and MathCAD are direct mathematics programs, whereas ANSYS is a finite element analysis and simulation program. MATLAB is the primary mathematics program for the MCET curriculum. MathCAD is an alternate option that is available for free as MathCAD Prime. For your information, we used to use MathCAD in the MCET curriculum, and there's still some benefit to learning it. ANSYS is one of the top-end mechanical engineering and analysis programs on the market today. It is miles ahead of the FEA modules and CAD systems like you may have used with SolidWorks or Fusion or Inventor. The way I like to describe the difference is that SolidWorks is primarily a CAD program that can do some FEA, whereas ANSYS is an FEA program that can do some CAD. Some years back, I co-authored a paper that was published by ASME in which we compared nonlinear dynamic analysis of some components in both SolidWorks and ANSYS. And ANSYS beat SolidWorks hands down. No one software is the right solution for every analysis. Some folks love using MATLAB and use it everywhere they can. Others prefer MathCAD. Some folks prefer SolidWorks or Fusion for simpler FEAs over ANSYS. Beyond simply personal preference, each tool has its own strengths and weaknesses. MATLAB is very good for matrices and systems of equations. And since it is the primary mathematics tool for our degree program, you will be required to use it for these types of analyses. MathCAD, on the other hand, is very good at basic algebraic computations, plus it handles nearly all common units used in engineering. By default, MATLAB doesn't handle units at all, and we will discuss the best ways to avoid getting into trouble due to this issue. Since many have already been exposed to CAD system FEA modules in other courses, we will use ANSYS for all FEA work. ANSYS is an advanced FEA software that provides superior analysis and setup techniques that CAD systems do not. We will mainly use it for static analysis, but it can also handle dynamics, thermal analysis, and computational flow dynamics, among other areas of interest. So let's look at each software program in a bit more detail. Starting with MATLAB, one of the key benefits is that it quickly and efficiently can handle thousands of iterations without any issue. Its language is considered to be a high-level programming language with some similarity to C++. Its original design intent and what it really shines at is matrix calculations. This is the basic user interface of MATLAB when you first open the tool. Note that there is no script file by default. However, in this course, we will be using scripts exclusively. Once you start a new script, it will add the window for the script file in the workspace. Keep the command window open below the script editor window. The command window is where we'll export our results and copy them into our assignments. The workspace window has some functionality in this regard, but it is less user-friendly. Based on how I learned MATLAB, you should start each program with the clear all, close all line shown here. Oddly, MATLAB gives me a warning when I add this, but I just ignore it without any issues. Note the key operations in MATLAB. Addition and subtraction are simply the plus and minus signs on your keyboard. Multiplication is the asterisk, that's Shift-8 on most computers. Division is the / key. You can assign variables by typing a letter or string of letters and setting it equal to a function. The semicolon is used as a line separator or an end of block command in old machine tool lingo. Variables are case sensitive. MATLAB has built-in constants like pi, and if you put the % sign in front of a line of text, it will allow you to type comments, and it will not evaluate anything after the % sign as code. This slide provides instructions on how to set up matrices in MATLAB. Further matrix instructions, this shows different ways to enter arrays and vector quantities. More information on matrices, and note this odd requirement near the bottom. When analyzing an array or matrix of data with either multiplication, division, or exponent operators, you need to precede the operation with a period or decimal point. That's just one of the odd programming requirements of MATLAB. This slide explains how to adjust the resolution of digits after the decimal point. This slide reviews how to use the basic mathematical operators in MATLAB. If you have ever typed out a formula in Excel, you are probably already familiar with these operators. Now we look at how to save files and scripts in MATLAB. There is effectively no difference in the saving process between files and scripts. You will need to designate a folder for MATLAB to search and save in. The file extension for MATLAB files is .m. MATLAB has strange restrictions on file names. You must start all file names with a letter, and you cannot use spaces or periods in the file name. I generally use underscores instead of spaces, and it seems to be okay with this practice. It is extremely important to keep track of your units in MATLAB. Most computational errors that I see students make in MATLAB are because of units. By default, MATLAB does not understand units. Thus, you need to keep track of them in your scripts. My recommendation is that you use only base units for all your calculations. That is meters, kilograms, newtons, newton meters, pascals, etc. If you mix, say, kilonewtons with megapascals and meters, your results may be off by several orders of magnitude. For U.S. customary units, we use pounds force, pounds mass, inches, inch pounds, and PSI. You can, of course, mix units as long as you correct for it in your script. But this gets very easy to lose track of and is a great way to introduce errors into your script. Use the commenting tool to define the units at the beginning of the script as shown. MATLAB is capable of generating plots and graphs, and we will use these functions in some of our homework problems. These are some of the advanced functions that MATLAB includes by default. And these are even more advanced functions. One way we will use MATLAB quite extensively is for simultaneous or systems of equations. For these operations, you need to install an add-on module called the symbolic toolbox. We will review installing this in class. The basic code for solving systems of equations is shown here. I recommend you copy it from the lecture slides and save it as a basic script. You can then use it as a template for your homework and exams. Note a critical caveat to systems of equations in MATLAB. You must enter the variables in the script lines in alphanumeric order. This means A comes before B, B comes before C, A1 comes before A2, comes before A3. If you have variables that have more than one character, like say RA1, RA1 has to come before RB1. If you don't pay attention to this, MATLAB will assign the wrong values to the wrong variables. So you may have the right magnitudes, but they'll be assigned to the wrong variables, and you'll wonder why. This slide goes into more detail on operations on multiplication, division, and exponents in matrix calculations. Now we move to MathCAD. By comparison, MathCAD is much, much easier to pick up than MATLAB. And you'll notice we have less slides on it for that reason. I have gotten colleagues up and running on this tool inside of 5 minutes. It will, of course, take longer to develop expertise with some of the more advanced uses. The primary interface is like a sketch pad. You can type anywhere you like and then move the commands around and organize them as you like. One caveat is that MathCAD reads the functions left to right, top to bottom. That means that if you define a variable and a function using that variable, and then you move the definition statement to be physically below the function on the page, it will no longer read the variable and it will give you an error. To define a variable in MathCAD, it's really easy. Type the variable, X, Y, Z, etc. It can be a single letter, it can be multiple letters, it can be a word. It doesn't care. Then press the Shift button and the colon button. That defines a variable. You can define it as a value or as a functional statement. Now, if you've defined it as a functional statement and you want to know what the result is, type the variable again, and this time press the equal sign and then enter. Then it will tell you what the result is based on the function for which you defined the variable. It is important to consider using subscripts. It's very easy to get. When you type your variable and you want to put a subscript after it, press the control button and the hyphen button. That's after the 0 if you're going along the number key at the top of your keyboard. The reason I strongly recommend using subscripts is because some letters you may choose to use for variables may also already be defined as unit in MathCAD. And if you start putting variables into a function that are also units, sometimes MathCAD will read it as a unit rather than a variable. So I just, by nature, just use subscripts for everything. If I've got L for length, I'll make it L subscript 1. Because L also means liters in MathCAD. So you just got to be careful about that. But with these few little caveats in mind, you can start using MathCAD like a pro the very first 10 minutes that you start using it. You can use MathCAD for matrices and plots. However, MATLAB is generally more effective in this regard, and that's what we'll use for these items in this course. ANSYS is an FEA, finite element analysis software, that takes a CAD model of a component and breaks it into hundreds, thousands, or even tens of thousands of sub-entities called elements. That's why it's finite element analysis. You can see the elements here. It then analyzes the predicted response at each element. The points at which each element contacts other elements are called nodes. The general process for an analysis in ANSYS is to create or import the CAD geometry, define the material properties, assign constraints, contacts, and loads. Then we run the analysis and then collect the results in the form of graphs or plots. There are two primary interfaces that we will use in ANSYS. The first one is called the Workbench. This is somewhat of a study manager tool where you store the study modules and you link them together and duplicate them, change their properties, etc. ANSYS Mechanical is the actual analysis tool. This is where you manipulate the CAD geometry, you apply the constraints and loads, and then evaluate the results. This slide gives you an overview of the ANSYS Workbench layout and the correct terminology for the various elements of the analysis. And this slide gives further details on Workbench and how each individual study system is broken up. The individual study is saved under a WBPJ file extension. Generally, we save from the Workbench interface, although saving from the mechanical interface is permitted. The WBPJ file is only the main interface for the given study. There are scores of subfiles that are needed to share the study with another user. To share ANSYS studies between classmates or with instructors, you will need to use the archive tool to create a WBPZ file, which is somewhat like a zip file for the entire study. However, you will never need to submit an ANSYS file to your instructor for this course. You will only need to submit reports using the outputs you get from ANSYS. This slide explains the user interface for the mechanical module of ANSYS. We will practice using all these tools in class. That concludes this video. Thanks for watching.